Hello everyone, my name is Skrzydło. I work as project leader in Appsilon, and today I will tell you a bit about how to improve your code and so what are the best practices to make your code durable. But before we start, let's first answer the question, why is that even important? So why you should make your code durable. So the scenario that I've often seen is, I think, something similar that Martin described. So you build a Shiny app. It's rather a small one. It can be a proof of concept or something that you build very quickly to just make your daily work faster. And then you take it to someone, that person really likes the application and sees a huge potential in it. So you take it to even more people, and that people have also some cool ideas how to even improve that app. So we are excited because your app is getting noticed. You sit down and you develop that new features. So then you are ready to take it to even more people, but more people also means more opinions. And then when you are trying to develop all that new features, what suddenly happens is that it turns out that it's not possible, that implementing even a small improvement can take a week or even a month. So what happens is that when you were building your initial app, you didn't make sure that your code will be possible to be further developed and just easy to maintain in the future. So if that sounds familiar, maybe you are facing such situation right now, this is the perfect place for you. I will cover 3 topics. That will be code encapsulation, tests, and project structures. So let's jump right to code encapsulation. So what is code encapsulation? As also Martin already mentioned, this is like taking your code and breaking it down to some pieces, putting them into the modules that are independent from one another. And why is it important? Generally, it just makes it easier because your code is well organized, so it's much easier for you to find a place that you actually need to modify. If it's easier for you, it's also much easier for your colleagues, so the whole cooperation is much easier, and it also allows you to follow the dry programming principle, so don't repeat yourself, because you don't need to copy paste your code, but you just have it ready and you can just very easily reuse it. So 3 ways of code encapsulation that I would like to cover today are Shiny modules, box package, and R6 classes. So first, let's take a general look on all of them and when to use them. And then we will go through each one of them in some more details to just give you a quick start. So if you have never used them, you will have just a tool to just start with that right tomorrow. So first, Shiny modules. This is just like a pair of UI and server. Of course, they're dedicated to Shiny. And you create that pair of UI and server and then embed it into your Shiny application. When to use that? Whenever you have any repeatable Shiny elements, especially, you have the same or very similar elements throughout your code, and that you want to change it to a module and just reuse it. Box package, this is a way of organizing your source code so that it's also a bit more rigorous with the dependencies, so what you import and export from such a module. And when to use that? Whenever you have repeatable code, you've extracted some functions to a separate file, and now you want to load that functions and use them somewhere else. And R6 classes, a bit more complicated concept, because this is an implementation of object-oriented programming in R. So if OOP programming paradigm is familiar to you, this will be very easy. If not, this is just a bit different way of thinking, I would say. And when to use that? Whenever you have objects that have that single responsibility and you want to put that in the object with the whole logic that comes with that. So for example, that can be a database manager when you have all the operations to get the data from the database, save the data, update the data, or even delete the data within that object. So let's now try to do some deep dive into all those 3. So Let me change the slide here. So first, Shiny modules. You need to first write UI and server functions. So for the UI, you will need ID here. Then you need to like initiate the namespace, and you just write normal UI code that you would just write in your Shiny app using IDs from that namespace. This is the only one difference. And in the server, very similar. You need to initiate the namespace and then just write standard server code, again with the IDs from the namespace. Once you have that two functions, you need to embed them into the Shiny app. So in the UI of your whole app, you just use the UI function directly with the unique ID. And in the server, you can use call module function, then provide that server function that you've just written and the ID to match with your UI, and then additional arguments if your server functions requires them. And that's it. It's very simple. So just to start with that, you can take whatever Shiny project you are working on currently, just pick one element. So it can be a plot, can be a table or a tab, and just copy paste that UI server code to a separate file, tweak the IDs and the namespacing, and then just embed that into your Shiny app, and you will have your first Shiny module ready and working. So the next concept, box package. So imagine that you have some functions, you extracted that functions to a separate file, and then you want to reuse that file. So you want to use that functions from that file in a different place of your app. So here, this is the first file, the file with the functions. And what you have here, first you need to import all the dependencies, so all the packages or maybe even other modules that you will be using. Here I'm importing stats package because I'm using it later, and you need to import it also like the box way. And then we have the functions. First is only internal, so it's only available within this module. And the second one is actually the one that I want to use also in other places. So I need to export it, and this is how I do it. Then if I want to reuse this module, so first I need to import it. Let's say that this file, so this file is located in the modules folder. So I import it here using the whole path without the .r. It's intentional. It's the box way. Then when you just want to use the function, you just call the module. The module name is the same as the name of the file because we haven't changed that. So this is my functions. It's also the name of the module, $, and the function that you want to use, and you can just use the function. If you will try to access any internal function, so the one that wasn't exported, you will get an error because it wasn't exported, so you cannot use it outside of the module. And the last one, R6 classes. So this concept is a bit more complicated. So if you would like to start with R6 classes, I highly recommend you to check Advanced R by Hadley. There is a whole chapter about R6 classes that will give you all the information that you need to just start, and everything will be perfectly clear for you after reading that. Today, just a very quick introduction, so you just can imagine how that works. So generally, this is the definition of the class car, and each class has fields and methods. Fields are somewhat like variables, and methods are somewhat like functions, and both of them can be either public or private. So it's similar concept as with exporting functions from the box package. So if something is public, you will get access to that. If something is private, you can only access it like from inside the class. And how to work with such R6 classes. So in order to generate new object of that class, you call the new function, and then the initialize, this is a special method, is called. So as here you can see, it requires gears argument. So we provide that, we set it to 10, and then the field gears. So this state that this is the field, public field of this class, is set to the value that you provided. and private field is defined here. The private field speed is set to default value, which is 0. Then when you print such an object, again, the special method print is called, and here you can see that we are printing the value of that private field speed, which is 0 as was set. You can use the speedup method, so the one that was created for this class. So it basically just increased the level of speed by 1. If you will try to access just the speed field directly, you will get null because speed is a private field, so you cannot access that value like from outside of the class. But if you print that object again, you can see that the speed is actually increased from 0 to 1 because we used the speed up previously. On the other hand, if you try to check the number of gears, you will get the correct value, the one that we've set, because gears is a public field, so you can access that value. So that was very quick introduction, but once more, I highly recommend that R6 chapter in Advanced R. So now we can move to the next concept, tests. I hope you have in mind already hundreds of reasons why you should write tests, but the 3 that are most important from my perspective is that they increase the quality, or they even ensure high quality of the product. They also increase cost effectiveness, especially in the long run, because it's much easier to find and fix a bug on the early stage of the development than later. And if it's easier, it just takes less time, which actually means that it costs less. And it's easier for debugging. If you have good coverage with your tests, you can easily, and you are, for example, developing a new feature that breaks something that was already working, the test will just guide you to that place that actually causes the problems. So if you haven't written any kind of tests yet, I highly recommend to start with unit testing. And here is an example of unit testing with testthat. How to start? It's very easy. Just pick a function that you want to write test to and write your first test. And this is how you can do it. This is the function that we will be testing, and this is the file with tests. So first, you use the context function to just describe what will happen. Then you use testthat function with some expect functions. There is a whole bunch of expect functions that you can choose from. Here I'm using expect equal and expect error. Generally, how to write good unit tests probably is another presentation, rather a long one, but if you haven't done that yet, like 2 tips from me would be to make sure that that your unit tests are actually units, so that you're actually testing one function, one functionality, and do not try to cover a lot in one test. And the second one, make sure that when you're choosing data to test, that you are testing just different use cases. So like here, I'm checking positive values, negative values, NAs, and what happens if I put character value in the argument. And of course, unit testing is just the beginning. It's not everything that you can test in your app, because then you can test also the whole components. You can test data, you can test API, you can test performance. But of course, we don't have time to cover all of them today. But one thing that I wanted to draw your attention to are user interviews, because I think that they're often, especially by tech people, maybe not appreciated, a bit forgotten, but I would like to tell you why they are so important. So user interviews, this is just a meeting with you and the user when the user actually uses the application and you are, I would say, watching it. And why is it important? Because it helps you, or actually it allows you to discover any conceptual debt that you may have in your app, because you are often so like involved into development and design of the application that you may not see that something isn't very logical. So this is the only way to just check if the app is actually understandable by other people. So what are the, I would say, golden rules to conduct a good user interview? So first, keep it one-on-one. Make it the first contact with the application, then you have the most insights. Prepare your script, so make sure you know what you want to ask your user to do with your app. At the beginning of the meeting, explain what is the goal of the meeting, and make sure that the user understands that you are testing the app, not the user, because this is something that users are often afraid of, that it's them who is tested, and this is not true. You are testing the app. Make sure that you ask business questions. So don't ask your user to just click the blue button. Ask your user to, for example, generate sales report for January, because this is what you're testing. You want to check if the user having the business task, business goal in their head, if they can actually perform that using your application. And last but not least, don't help your user. This will be very tempting because users will ask you questions how to do that, but try not to lead the user, rather try to encourage them to explore the application. You can also ask them to so that they say loud what they expect after clicking button, changing tab, and what they feel, if they are surprised with what they see, of if this is something that they expected, because this is how you gather information about how people actually interact with your application. And the last part of this presentation, project structure. And why is it so important? So first of all, it makes the project well organized, which means, again, it's just easier to understand. It's easier to understand for you, so it's easier. It makes the development faster because you know exactly where to look for a place that you need to modify. It's very it makes it much easier for new people joining the project, because especially if the project is big, they don't need to learn the whole structures and so on. They will be very easily it will be very easy for them to just find that place that they should concentrate on. And the example project structure that I have here, I will point out some of interesting parts in a second. But first, what is most important to remember is that every project is different, so we'll have different needs, and the project structure should serve your project and its goal, not the other way around. So just make sure, so just don't take this project structure for granted. Just make sure that you each time think about what's needed in your project. So here, what do we have here? First of all, we have README, and keep your README live and updated. It should be there from the very start of the project until the application exists, and try to keep it actually on whenever there is a need. It will help a lot. It will help a lot you, and it will help all the team members that are currently in the team but may also join the team in the future. Here in the app catalog, we have modules. So this is the great place to put all the Shiny modules or the R6 classes that you've created. Of course, use descriptive names. This is just an example, but generally you should make sure that you use descriptive names. You may even need some more structure here, so some additional folders to group modules that are somehow logically connected with each other. In the utils catalog, you may have some helper functions that you've extracted and that you want later import in some modules or in a global file as a module, so using the box package. And again, the same here. You may you probably will need some more structure to also group those pieces of the code that are connected with each other. And tests, so test catalog, we also very extensively use linter, so to check also for the code style that we use. And here the catalog with tests, so this is the place where you should put that file with your test and the main file that runs the tests. And that's all from me. Thanks a lot. If you need help scaling your application, don't hesitate to reach out to me. Also, if you're interested in working with us, you can check our careers page. We have some open positions. If you have any questions, you can also contact with me. Yeah, and I think that's all. Thank you.